Dear students, we'll discuss today some numerical problems related to series connected resistances and the voltage divider rule. Okay. In the previous problem, we have discussed that if resistors are connected in series, then equivalent resistance can be given by the sum of individual resistors connected in series. And voltage divider rule, for example, if two resistors are connected in series of value R1 and R2, if they are connected to a supply voltage V, then this supply voltage is divided into V1 and V2 for R1 and R2, and this element voltage V1 is given by total voltage into resistance of that element divided by sum of resistors connected in series. Similarly, now V2 will be equal to what? V into R2 divided by R1 plus R2. So we'll try to use these formulae to calculate currents, equivalent resistance and all. So at the end of this session, you should be able to determine the current and element voltages for series combination of resistors using voltage divider rule. So as we discussed before, that if three resistors are connected in series, that can be represented with a single equivalent series resistor Rs given by R1 plus R2 plus R. Okay. And the current will be same throughout. So this is what we have seen the derivation already. Yeah. So coming to a problem, two filament lamps means bulbs incandescent bulbs. We represent like this. So there are two bulbs, A and B. Okay, lamp A and lamp B. Uh, Two filament lamps A and B take 0.8 amperes and 0.9 amperes respectively when connected across 110 volts supply. The lamps can be represented as a resistor. So you can take this as a resistor RA and this as a resistor RB. So assume that there is a voltage of 110 volts, and if I connect these lamps to this, it is given that this RA will take 0.8 amperes and RB will take 0.9 amperes. So from this I can find out what is the values of this resistance. RA will be equal to what? RA will be equal to 110 divided by 0.8. So RA is 110 divided by 0.8, that is 137.5 ohms. Similarly, RB will be equal to what? 110 divided by 0.9 voltage divided by current, that will give 122.2 ohms. So once I get this one, what is next asked? Calculate the value of current when they are connected in series across a 220 volts supply, assuming the filament resistances remain unaltered. Now, instead of connecting the bulbs directly to 110 volts, now these two bulbs are connected in series. If I connect them in series and then connect it across a voltage of 220 volts, then what happens? That is what is asked. So we have these RERB values now. So now I can consider two bulbs in series as the two resistors in series connected to 220 volts supply. 220 volts supply. So this is RA, this is RB. Now I can calculate current now here. I will be equal to what? I will be equal to total voltage divided by total resistance. So that is what is asked. Calculate the value of current when they are connected in series. So I will be equal to 220 total voltage divided by RA plus RB. So by that you will get to what? Current as 0.847 amperes. 0.847 amperes. Similarly, it is asked also find the voltage across each lamp. What will be the voltage across each lamp? It is nothing but voltage divider rule I have to use. Let us say this is VA and this is VB. So what will be VA equal to? I'll write here. VA equal to total voltage V into resistance of that element divided by sum of the resistors connected in series. So we can substitute the values. All the values we know. This is 220, RA, RB we know. So we can calculate. So by that you'll get voltage across lamp A is 116.6 volts and voltage across lamp B is 103.5 volts. Yeah. Next problem. Determine the resistance and power dissipation of a resistor that must be placed in series with a 75 ohm resistor across 120 volts source in order to limit the power dissipation in the 75 ohms resistor to 90 watts. So here in the figure it is given that 75 ohms is connected to one resistor R, and this R is the parallel combination of this R is the parallel combination of spaced in series. Determine the value of resistor in order to get, okay, so this R value you have to find in series with the resistor. Okay, this single resistor. So now we can see here I square into 75. Now let the current be I. Let the current be I. Applied voltage is 120 volts plus minus. So current I is coming. So what will be what will be this current? The same current I flows here. Okay, and it is given that the power that is dissipated here is 90 watts. The current should be such that I square R for this one should be 90 watts. So 90 watts should be equal to what? I square into 75. So I can find I here, and that I is square root of 90 by 75, that is 1.095 amperes. Now once I get this current, this is 1.095 amperes. So this current I have got, this current I have got. Now what is asked is determine the resistance and power dissipation of a resistor that must be placed in series with a 75 ohms. So once I get this uh, current value, now I can find this. This total current I should be equal to what? 120 divided by total resistance 90 plus R plus 75. So I can find R. So R will become now 34.6 ohms. And power dissipated in this resistor will be what? I square into R. So that becomes 41.5 watts. Please go through carefully, you can understand. So voltage divider circuit, we know that in case of voltage divider circuit, the total voltage is divided into small portions of V1, V2 across R1 and R2. Okay. And we have seen these equations. So let's solve a problem. What is the drop across the 150 ohm resistor in the figure given? So the 150 ohms is there. You can see here 15 volts, 47 ohms, 22 volts, 150 ohms is there. And there is only one closed path, that's all. So now this is 22 volts and this is 15 volts. So therefore this voltage is higher. This will give current now. Current will be same throughout. Let the current be I. So as this is at higher voltage, this will give current and this 15 volts battery will take the current. Okay. So or you can say that battery is charging here. It is discharging, it is charging here, like that. Now what will be I now? To find I, you can apply KVL in anti-clockwise direction. If I move from here, if I start, there is voltage rise. So applying KVL to the circuit, I get voltage rise 22 and current is passing here. So plus minus. So minus I into 47. Next here, this is plus, this is minus. We are moving like this, plus to minus. So minus 15. Next, this is plus, this is minus. Current is coming like this, plus minus. Okay. Then it becomes minus 150 into I. So we have come to the original point equal to 0. Now we have here only unknown variable I. You please solve that one. Next one, a resistor of 3.6 ohms is connected in series with another resistor of 4.6 ohms. So we have two resistors. This is 3.6 ohms and another one is 4.56 ohms. what resistance must be placed across R6. Now, if I connect one extra resistor R, so that total resistance of the circuit shall be 6 ohms. So that this total resistance RT should be equal to 6 ohms. Okay, what is RT now? So this parallel combination I can reduce into a single resistor. What is that one? If I call this one as R1 and this is R2, now RT will be equal to what? R1 plus R2. But what is R1? R1 is two resistors in parallel. What is the equivalent resistance? For parallel connected resistors, R equivalent is equal to R1 into R2 divided by R1 plus R2. In this case, which are R1, R2? Rn 3.6. So R into 3.6 divided by R plus 3.6 plus R2. Okay, you know RT 6 ohms, you know R2 4.56 ohms, 3.6 means only R is left. So you please solve this one. You have to get answer as 2.4 ohms. Answer is 2.4 ohms. Yeah. Students, we have discussed on the series connection of resistors and voltage divider and one or two numerical problems. So based on the idea, you try to solve the exercise problems in the textbook, and hence you will be able to determine the circuit current and element voltages for series combination of resistors using voltage divider tool. So refer this textbook, K. Umarov, Basic Electrical Engineering. You can refer this chapter 1, topic 1.3.4. Okay, thank you, students.